Wherever you look within the Android operating system, you will notice presence of the Aidl interface. In fact, most of the communications within the platform happen through an AIDL interface. It's the primary mechanism for inter-process communication in Android. That's why we need to understand AIDL and learn how to use it effectively. Hello and welcome to my channel. My name is Muhammad. I'm gonna tell you what you need to know about AIDL through a series of videos from the application layer to health services. Let's start from the beginning. AIDL stands for Android Interface Definition Language. It's an IPC mechanism provided by Google and Android. Basically, it's a form of remote procedure call that allows you to invoke methods on a remote object. This makes AIDL one of the key features or facilities offered within the Android platform. For your information, AIDL is not the first IPC mechanism introduced within an operating system. It's one of many interface definition languages that enable inter-process communication between different processes. I said processes. Yes, these processes can exist within the same system or across separate systems. AIDL acts as a bridge, enabling seamless communication between these processes or systems. But what is AIDL used for, and how should we use it, or where is it commonly applied? These questions could help clarify the role of AIDL. As I mentioned earlier, AIDL help you to invoke procedures and methods for two main purposes. The first is transmitting or receiving data, and the second is executing a remote function. Now we know that what AIDL could do. Let's move on. There are two primary scenarios where AIDL could be used. The first scenario is having them in the same application. The caller and the server are part of the same application, meaning the interface is implemented within the same memory space, which is clear how it looks like. However, the second scenario involves separate applications and separate memory spaces. In this case, the caller and the server exist in separate processes. The interface is implemented in a different memory space but can still be accessed by the calling application. AIDL enables communication between these processes, letting an application to interact with the interface regardless of whether it resides in the same or different memory space. But it's not as simple as this diagram illustrates. Both sides should fulfill the minimum requirements. First, an AIDL interface. Second, we need a client application. And last one is a server application. Now, we explore how AIDL works in more detail. Imagine there is a client application, a standalone application that you have developed, potentially with a user interface and multiple components. Then a server application or host application provides the specific functionalities your client application requires. The AIDL interface is a contract that enables communication between these two applications. Here's how the process works. The first step is to define an AIDL interface used in the communication. Next, the server application should implement the interface and have a bound service that returns a handle of implemented interface during the binding events. The client application binds to the server application service, which exposes the AIDL interface. After successfully binding, the client application receives a reference or handle to the remote AIDL interface implemented on the server. Since the client application includes the AIDL interface in its code base, the methods are available for remote invocation. From that point onward, the client can seamlessly invoke methods on the server as if they were local. This setup allows the client application to access and utilize functionalities provided by the server application, even though the two operate in separate memory spaces or processes, which it doesn't matter. This mechanism simplifies inter-process communication or IPC, making remote method invocation straightforward and efficient. That should be sufficient as an introduction to AIDL. Now is the right time to delve into various scenarios and combinations that might arise when working within the Android platform, particularly when using AIDL as an IPC mechanism. When working within a platform, whether developing an application or a service, interaction between the application layer and other layers can involve various scenarios. These scenarios can influence the implementation approach, particularly in terms of adjusting security measures or writing specific code. Therefore, it's important, perhaps even necessary, to understand which features or considerations are relevant in each scenario. The first scenario involves two regular applications that utilize an AIDL interface as an IPC mechanism. In this case, one application acts as a server, providing specific functionalities, while the other serves as a client. The client application binds to the service provided by the server, and once it obtains a handle to the AIDL implementation, it can invoke the defined functions. This setup is straightforward and relatively easy to implement. There are a few key points to keep in mind. First, these applications operate at a normal API level. It means they are typically installed through the Google Play Store or other sources, or even via ADB in testing scenarios. They don't have direct communication with system services. While the Android framework facilitates the AIDL interface communication between these two applications, it doesn't allow them to directly access core system services. For example, services like the location manager involve a different type of communication between a normal app and a system service via AIDL. However, that's a separate topic we will cover later. For now, the important considerations are these applications are installed through online store or similar methods. Their permissions are limited to user level access, and there are restricted to specific versions of Android SDK APIs that they are allowed to use. This scenario provides a clear example of how AIDL can be utilized for communication between applications without involving direct interaction with system services. The second scenario involves a normal application interacting with a system service. This service could be something developed by an OEM or one of the Google's core services within the platform, such as the location manager, package manager, or other similar services. In this case, there are specific considerations that we need to know. The first one is custom permissions. If the system service is a custom or pre-installed service developed by OEMs, it often defines custom permissions that both the application and the service need to declare. These permissions can include different protection levels that indicate the level of access. As I said, protection levels. For certain services, the permissions might require additional security measures. For example, both the applications and the system service might need to be signed with the same cryptographic key. Alternatively, there might be no strict protection level, allowing more. The third scenario, it involves two system or privilege apps communicating through an AIDL interface. These apps are typically included in the system image or vendor image, granting them unrestricted access to system APIs and system level permissions. In this case, these services and applications often bypass certain security restrictions due to their elevated privilege. However, this is done with caution and awareness, not blindly, as they are protected by SE Linux policies and are usually signed with platform keys. The key points which I can bring up here is the first one is AIDL integration. The AIDL interface in this scenario usually is part of the platform, including as a library or module that is built into both the platform and the applications. The second one is the application storage. This system or privilege apps are typically will be stored in some specific folders in system image or vendor image, or we can say system or vendor partition. And the last one is about the security measure. Despite their elevated access, these apps are safeguarded by SE Linux policies and are signed with the platform keys to ensure they meet the platform security standards. This scenario highlights how privileged applications with careful implementation and robust security measurements can communicate seamlessly through an AIDL interface as part of the Android system. The last scenario that I would like to explain here involves a system or privileged application developed using the Android framework with system level permissions communicating with a native service or process developed in C++. This scenario differs from the previous one mainly mainly because it involves a native process which introduces additional complexities. However, as with the last scenario, AIDL interface will still be part of the platform. Similar features like being stored in system-related folders and included as a library or module apply here as well. There are some notes or maybe some points which I would like to highlight. The first one is about the native process. The communication involves a native service or process developed in C++, which requires more careful handling compared to Java-based components. The second point is about the custom SE Linux policies. Due to the native nature of the service, more specific or custom SE Linux policies are typically needed to ensure secure interaction between the application and the native service. And the last one is about integrating into the platform. AIDM interface is built into the platform and shared between the application and the native process to ensure a robust and seamless interaction. This scenario is likely the most complex, but still adheres to the general principle of security and platform integration, making it a key consideration when developing on the Android platform. So far, we have covered an introduction to the AIDL interface, how it works, and its usage within Android as an IPC mix. We also explored various scenarios that might arise when developing on the Android platform, which highlighted key characteristics and considerations for such applications. Next, we will dive into the technical specs of implementation, and we will start by defining an AIDL file to see how we can make an AIDL interface or library to be used in other applications. These details will be covered in the upcoming videos. Thank you for watching, and I'll see you in the next course.